Alright, so we are with exercise 29. What if? Here's the next script of Python you will enter, which introduces you to the if statement. Type this in, make it run exactly right, and then we'll see if your practice has paid off. Oh man, I already did this. But anyways, okay. Alright, I kinda have to do these exercises, so let's go with 29. What if? Alright. Okay, so people 20, cats 30, dogs 15. Huh. People 20, cats 30, and dogs 15. Okay. We have if people less than cat, too many cats, the world is doomed. If people less than cats, too many cats, that's the what is happening? World is doomed. Okay. And we have if people greater than cat. If people greater than cats, then we have not many cats, the world is saved. Not many cats, the world is saved. And we have if people less than dogs. If people less than dogs. We have the world is drooled on. And we have if people greater than dogs. Then we have the world is dry. Then we go dogs plus equals 5. Then we have if people greater than equal to dogs. People greater than equal to dogs. Then we have people are greater than or equal to dogs. People are greater than or equal to dogs. I'm sorry. Then we have if people less than equal to dogs. Less than equal to dogs, then we go. Then we say people are less than equal to dogs. People less than equal to dogs. And we have people equals to dogs. People are dogs. And that is it. Okay. C study drill. What do you think if the if does under the code? Why does the code under the if need to be intended 4 spaces? What happened if it isn't intended? Can you put other Boolean expressions for exercise 27? And what happens if we change the initial value for people, cats and dogs? Okay, common student question. Let's try if this works. Okay, to create a new directory, and F. Alright, so in the last exercise we worked out some if statements and then tried to guess what they are and how they work. Before you learn more, I'll explain what everything is by answering the question you had from previous study drills section. You did the study drills, right? Okay. What do you think of the if statement? What do you think the if does to the code under it? An if statement creates what is called a branch in the code. It's kind of like those choose your own adventure books where you are asked to turn up one page if you make one choice and another if you go to a different direction. Okay. Then we have if statements tells your script if the Boolean expression is true, then run the code under it, otherwise skip it. Why does the code under the if need to be indented 4 spaces? A colon at the end of a line is how you tell Python that you are going to create a new block of code. Okay. And then indenting 4 spaces tells Python what lines of code are in that block. This is exactly the same thing you did when you made functions. Alright. And what happens if it isn't indented? If it isn't indented, you will most likely create a Python error. Python expects you to indent something after you end a line with a colon. Can you put other Boolean expressions from exercise 27 in the if statement? Try it. Yes, you can, and they can be as complex as you like. Although really complex things generally are bad style. Yeah. What happens if we change the initial value for people, cat and dogs? Because you are comparing numbers. If we change the numbers, different if statements will evaluate true and the blocks of code under them will run. Go back and put different numbers in and see if you can figure out in your head which blocks of code will run. Okay. Compare my answers. Okay. So compare my answers to yours and make sure you really understand the concept of a block of code. This is important when you do next exercise, when you write all parts of if statements that you can use. Okay. At this one and make it work too. Right, my man. We have, what do we have? We have 30 people, 40 cars and 15 trucks. Okay. People 30, 40 cars and trucks. Trucks 15. Then we have if car greater than people, we should take the cars. Cars greater than people, then we should take the cars. Then we have LF if car less than people. Okay. LF cars less than people, then we say we should not take the cars. And finally we got else, then we can't decide. Then we have if trucks greater than cars, that's too many trucks. And we have LF trucks less than car, maybe we could take the trucks. could take the trucks. So finally we have else when we can't decide. And if people greater than trucks, alright, let's just take the trucks. And else, fine, let's stay. Let's stay home then. Okay, that is all. Yeah, what you should see. Okay, study show. Try to guess what L, F, and L are doing. Change the number of cars, people, and trucks, and then trace through each if statement to see what will be required. Try some more Boolean expressions like cars greater than people or trucks less than cars. Above each line, write a comment. Okay. Common student questions. What happens if multiple LF blocks are true? Python starts at the top and runs the first block that is true and will only run the first one. Okay. Okay, then we have making decisions. In the first half of this book, we mostly just printed out strings and called functions, but everything was basically in a straight line. Your scripts ran starting at the top and went to the bottom where they ended. If you made a function, you could run that function later, but it still didn't have the kind of branching you really need to make decisions. Now that you have if, else, and elf, you can start to make scripts that decide things. Okay. Okay. Alright, okay. So in the last script you wrote out a simple set of tests asking some questions. In this script you will ask the user questions and make decisions based on their answers. Write the script and play with it quite. Okay, I can do that now. I can do that, but what do I really want to? Loops and lists. Okay, now we're getting in loops. Alright. Okay, so we have loops and lists, while loop, accessing element, branches and functions, designing and debugging. Nice. Symbol review, doing things to list, dictionaries, module classes. Okay, so I'm really close. Make a game. Alright. So we have to get through each exercise and then we can reach our goal. Right. This is exercise 31. Alright. That is making decisions. So we start with print. You enter a dark room with two doors. You enter a dark room with two doors. It says, do you get through door 1 or door 2? Do you get through door 1 or door 2? Then we have door. Okay, then we start a if door equals 1. We go print. Okay. There is a giant bear here eating a cheesecake. There is a giant bear here eating a cheesecake. Then what do you do? And this is what do you do? And then we will prompt them with 1 is take the cake. Then another is scream at the bear. You have bear equals input. Then if bear is 1, the bear eats a face off. Okay, so we have then if bear 1, if bear equals 1, then we go print the bear eats your face off. Good job. Then eats your face off. Good job. Then else bear equals 2, the bear eats your leg off. Eats your legs off. Good job. We have a else statement, that is, well, doing this is probably better. Well, doing, and I do have to add this, probably better. Bear runs away. Then we reach to LF2. Okay. 1 or 2. Your body survives powdered. Okay, your body survives powered by a mind of jello. That was good job. Um, okay, good job. Then print. The insanity rots your eyes into pool of muck. Good job. You stumble and fall down on a knife and die. Good job. Okay. So we go LF. It's the time which you get. LF door equals 2. Jump here. Make a little space. Yeah. Okay, then we go. You stare into the endless abyss at Cthulhu's retina. Stare into the endless abyss. Is there double B now? Cthulhu's Cthulhu retina. Then print 1 blueberries. Blueberries. Yellow jacket clothespins. And third is understanding revolvers yelling melodies. Understanding revolvers yelling melodies. Then we take the insanity. Insanity equals, okay, insanity input. And we have if insanity equals 1 or insanity equals 2. Insanity equals 1 or insanity. No, I would always do this. Yeah. Insanity or insanity. Then we go, your body survives powered by a mind of jello. Your body survives powered by a mind of jello. And we have else, okay, when we have print, good job. Else the insanity rots your eyes into a pool of muck. Good job. The insanity rots your eyes into a pool of muck. Good job. Then we have else. You stumble around and fall on a knife and die. You stumble around and Good job. That is indeed okay. The key point here is that you are now putting if statements inside if statements as as code that can run. This is very powerful and can be used to create nested decisions where one branch leads to another and another. Make sure you understand this concept of if statements inside if statements. In fact, do the study drills to really nail it. Okay. We have make new parts of the game and change what decisions people can make, expand the game out as much as you can before it gets ridiculous. Write a completely new game. Maybe you don't like this one, so make your own. This is your computer. Do what you want. Okay. Can you sorry, can you replace else if okay can you replace else with sequence of if-else combinations? You can in some situations, but it depends on how each if-else is written. It also means the Python will check every if-else combination rather than just the first false one, like it would if else. Try to make someone figure out. Okay. How do we tell whether a number is between a range? Okay, you have two options: 0 or okay, 0 x or here, which is a classic notation, or use x in range. How do I tell whether a number? Okay, so it will check first is 0 less than x, 0 less than x, and this will be false. So 1 1. Okay, if I wanted more options in elif, if I want add more elif blocks. Okay. Syntax error bear. Yeah, okay. Colons. Yeah, okay. So door 1, take the cake. Nice. Good. Okay. So okay, you have two options use 0 less than x less than 10. Okay, so I can do that. Let's try this. I go x equals 9. So I want 0 less than x less than 10. True. Huh. Oh, okay. So this statement 0 is false, 1 less than 10 is true. Okay, and if I had x equals 11, then 0 less than 1 less than true. 0 less than x less than 10 is false. Ooh. So 0. How does this works? You know that these are left associative, right? Let's start from the left. So first they will compare this expression, which would result in true or false, right? Okay, if 0 is 0 0 less than x would result in 0 less than x results in true, because 0 is less than. Okay, so 5 0 less than x true, okay, x less than 10 false. Huh. So is it taking the and when it does this, false, because this statement is true, and then true it would give, it returns true here. Okay, I am not quite sure how this works. Loops and lists, yeah, we'll come to loops and lists later, but it is necessary that I understand 0 less than x less than 10. Okay, so if I do the same thing in any other language, right, let's try C. Okay. Let's say comparing numbers. I think it will work a little different here. Okay, that is all I know. Okay, so I go int x equals 9. Alright, if I write 0 less than x less than 10, print correct else, okay, else incorrect. Okay, I know here 0 less than x, this will result in 1, right, because this is true, and then 1 less than this shit, right. Correct. Huh. What is happening, my man? X variable. It's true. Okay, 1 less than 10 is also true. Right. But okay, that I get. That this is true. Then 1 less than 10 is also true. If I go 11, it should also go correct. Right? Correct. Yeah. Okay. So that is, this is not how it works here. Okay, so I got that right. No need for this. Right. But this this works a little different here. Okay. So booleans are evaluated in Python. Okay. Explicit boolean comparison. Okay, return true based on comparison of two results. Okay. Truthiness and falsiness of objects. Let's ask Gemini. How is the expression 0 less than x less than 10 evaluated in Python. Okay, in Python the expression is chained comparison. Okay, it's evaluated differently and more intuitively than in many other languages. Okay, here's a breakdown of how Python handles it. Chains comparison. Okay, Python automatically breaks down the. Okay, and yeah, that is what I thought. Then it ands the value. Okay, so important point. In Python, if you write 0 less than x less than 10, this is equivalent to 0 less than x and x less than 10, and the result would be the and logical end of both answers. Okay, so that's what's up, right? So that's why. Okay, so this is the same. Then okay, what if I wanted? All right, then we have loops and lists. Okay, you should now be able to do some programs that are much more interesting. If you have been keeping up, you should realize that now you can combine all of the things you have learned with if statements and boolean expressions to make your programs do smart things. However, programs also need to do repetitive things very quickly. We're going to use for loop in this exercise for build. Okay, we are going to use for loop in this exercise to build and print various lists. When you do the exercise, you will start to figure out what they are. Okay. So when you are going to use a for loop in this exercise, okay, I think yeah, GitHub, right? On GitHub, we had NumPy, NumPy. It is entire okay Python, but the main parts are written in C, right? Right. Okay, C++, I think. Okay, and psort. Hmm. Less than. Okay, so that's how it works. SIMD sort. Okay, quick sort. These are all NumPy code source. Okay, in the source we have simd.c, simd, single instruction, multiple data. Okay, so we perform these things. Self, args, that's how it works. Right? It is written in C. Okay. Alright, thanks. Alright, so However, programs also need to do repetitive things very quickly. We're going to use a for loop in this exercise to build and print various lists. When you do this exercise, you will start to figure out what they are. I won't tell you right now. You have to figure it out. Okay. Before you can use a for loop, you need a way to store the results of a loop somewhere. The best way to do this is with lists. A list is exactly what the name says, a container of things that are organized in order from first to last. It's not complicated, you just have to learn a new syntax. Okay, first here's how you make lists. Okay, you start the list with left bracket which opens the list, then you put each item you want in the list separated by commas, similar to function arguments. Lastly, end the list with a right bracket to indicate that it's over. Python then takes this list and all its content and assign them to the variable. Okay. Warning: this is where things get tricky for people who can't code. Your brain has been taught that the world is flat. Remember in the last exercise where you put if statements inside if statements, that probably made your brain hurt because most people do not ponder how to nest things inside things. In programming, nested structures are all over the place. You will find functions that call other functions that have if statements that have lists with list inside list. If you see a structure like this that you can't figure out, take out a pencil and paper and break it down manually. Okay. So we create okay, exercise 32. 32, I think it's called loops and lists, right? Loops and lists. Okay, so first we'll create a list, the count 1 2 3 4 5. 1 2 3 4 5. Then we have fruits: apple, oranges, pears, apricots. Fruits, apples, oranges. Then we have pears and apricots. Then finally we have change equals 1 comma pennies. And we have 2 comma dimes. And we have 3 comma quarters. Okay. Now this first kind of for loop gets through a list. Okay. The first kind of for loop gets through a list. Okay, so for number in the count, we go print this is count. This is count, then we type in the number. Okay. Then same as above, for fruit and fruits, print f a fruit of type fruit. Also we can go through mixed lists too. Notice we have to use some since we don't know what's in it. Okay, this is we can go through mixed list to notice we have to use since we don't know what's in it. So I change again print I got then you use a range function to do 0 to 5 counts. Okay, we can also build list. First start with an empty one. Okay, so we can also build list. First start with the empty one. So we have elements equals nothing. Then use the range function to do 0 to 5 counts. Range function to do 0 to 5 counts. And for I in range, I in range 0.6. Then we have print. Adding I to the list. Is a function that lists understand. Elements dot append is a function that lists understand. And elements dot append I. Then we can print them out too. Print them out too. So for I in elements print if element was I. Okay, so this guy. Alright, great. Go to what you should see. A fruit is this. And adding 0, 1, 2. Oh, that's why. Okay. Then we have take a look at how you used range. Look up the range function to understand it. Okay, let's try python-m pydoc range. Okay, this is range function. Range stop, the object range start. Okay, so you can it can give a range stop. Where do we want to stop? Then we can also provide a start and a stop with step. Okay, stop and then a step. Okay, return an object that produces a sequence of integers from start inclusive to stop exclusive by step. Range I, j produces I plus 1 up to j minus 1. Start defaults to 0 and stop is omitted. Range 4 produces 0, 1, 2, 3. These are exactly valid indices. For a list of 4 elements. When the step is given, it specifies what What's up with this? Is it a list? Step is given, it specifies the increment or decrement. Okay. So could you have avoided the for loop entirely on line 22 and just assigned range 0 to 6 directly to elements? I think so. But then elements. Okay, that is list comprehension, right? Okay. Find the Python documentation on lists, dear partner. What other operation can you do list besides append? Okay. Then let's try list. Okay, built in mutable sequence. If no argument is given, the constructor creates a new empty list. The argument must be a iterable if specified. Okay, we can. Alright, so I can create a list like count list equals list iterable range 0 comma 6. Then for I in count list I can print I. Right, I think that works too. Right, there we go. Okay. So you can also create a list like this. Provide an iterable object as the argument to the list constructor. Okay, right. Operations. This is right. Okay. How do you make two-dimensional list? This is the list like this. Aren't list and array the same thing? Depends on the language and implementation. In classic terms, the list is very different from an array because of how they implement it. In Ruby, though they call these arrays, in Python they call them lists. Just call these lists for now since your Python would call them. Okay, why is the for loop able to use a variable that isn't defined? The variable is defined by the for loop when it starts, initializing it to the current element of the loop iteration each time through. Okay. Why does for I in range only loops 2 times? Okay, range function is inclusive of the first element and exclusive of the second one. Why does elements append? What does elements append do? It simply appends to the end of the list. Open up Python shell and try a few examples with lists. Okay, so I have done 1, 2, 3, 4 exercises, and we are trying to do 4 more tomorrow. Okay, that's it for today.